Hello, everyone. My name is Hoyt Kesterson. I'm a senior security and risk architect with Iridium. I'm in Phoenix, Arizona. I wish I could be with you in Stockholm. I love that city. I love the Vasa. However, it's a distributed meeting, geographically distributed, some people virtual, so we'll have to do it this way. We all know why we're here. It's because bad people really want to get a hold of passwords, or as NIST now calls it, your memorized secret. I'm here to talk about the payment card industry, which has a lot of acronyms associated with it. I'm not going to go through all of them, but I'm going to talk to you about what payment cards and what's going on with payment card industry and passwords at this moment. So the payment card industry is essentially the card brands, Visa, American Express, so forth. The people who do processing, the acquirers, the banks who handle credit card charges. And they used to all have their own assessment mechanisms. In other words, Visa would have you go out to look at their card processors to make sure that they're doing things in a secure fashion. However, they wanted to actually consolidate this view. So they got together and they formed something called the PCI SSC, the Security Standards Council. And these are the people that are responsible for the standards that you hear about having to do with the credit card industry. The main one you mostly hear of is the one called the Data Security Standard, the DSS, but there are a lot of others. Now, I happen to be a fan of the DSS. I've been doing this for so long that I remember when we couldn't get anybody to think that security was important. You know, basically, if you were a manager, you were in a kind of a bind because if you spent a lot of money and did good security, then you didn't have problems, and you couldn't prove that the reason you didn't have problems it wasn't you. And the governments were helpful. The United States government still really isn't a great lead on this. They keep talking about industry leading it, and industry doesn't do leading it. Well, the financial industry, and particularly the payment card industry, we're faced with rampant fraud and essentially not the best processing by some of the merchants, by some of the people doing the thing. So they did this thing called the DSS, and I like it a lot better than a lot of standards that are frameworks and so forth, because the DSS, the frameworks are kind of like, well, you know, if you do this, maybe you've got some security. The DSS is very prescriptive. You will do this, you will set it to at least this value. Now, the interesting thing about it is that it is prescriptive, but it allows you to, if you want to basically have a different approach. And you do that in the current standards by something that's called a compensating control, where all you say is the technique that I have is at least equivalent to addressing the risk as the technique that's specified in the standard. So you get a lot more flexibility. The other thing I like about this standard, this entire industry, is the fact that it's preemptive. It really doesn't wait until essentially there's been a breach and therefore you've broken the law. It sends assessors out, external assessors out annually, okay, and maybe more depending on what's going on, to basically make sure that you're complying to the standard. Now, that's not as good as it could be, because some people will still do standards as will still basically prepare for a meeting with the assessment team, and then they pop the corks when the assessment team leaves because the audit's over and we can go back to business as usual. The other interesting problem is that essentially the payment card industry has teeth in this standard, in the fact that it can charge penalties or higher fees and so forth. But there's a limit there. The limit is the fact that you actually have to be making charges, doing transactions with credit cards. And therefore, entities like credit monitoring services and so forth, who have your credit card information, but really aren't doing anything with it, they're not making charges, they're not really held to the PCI DSS standards. They're not required to have assessments. And that's exactly why when they have these massive breaches and they're doing things, we have to talk about them in terms of fixing their problems as opposed to being preemptive. Now, the PCI standards that are in effect now, it's more than the DSS. There's the report on compliance, which is what the QSA, the assessor, fills out, and the attestation of compliance, which is what the person, which is what the organization which has been assessed can actually provide to other organizations to show that in fact it is compliant. If you're an organization that really isn't that large, it doesn't do that many transactions, you can actually do the self-assessment questionnaire, or SAQ as it's called. That essentially there are different kinds of SAQs that talk about different environments you might be in. For SAQ, for instance, if you just run virtual terminals. There's the point-to-point encryption, P2PE, which basically says, well, hey, if you've actually got one of these neat card reader devices that encrypts the credit card in the card reader, and you, the merchant, never even see the credit card number, it goes to the processor, then you can actually exclude yourself, declare out of scope a lot of the stuff the DSS standard says you have to do. That's called P2PE. The PIN Transaction Security Point of Interaction standard, PTS standard, is the one that sets all the requirements for how you actually implement that in a capture device. Okay. And then there's this new thing. This is always ongoing. Even though the DSS has been around for a while, this is always ongoing. And recently they did the Software Security Framework. And what they said was, they used to have this thing called the payment application, the PADSS, right? And that was the rules you had to follow if you were writing applications that people would acquire off the shelf and that were going to process credit cards. And then they had other rules that had to do, well, what if you're developing your own code? And they've actually kind of merged this all together now into something called the Software Security Framework. And this is a recent standard. So standards, even though the DSS has been a while since it's been changed, there are new standards ongoing all the time. Now, a long time ago, when I used to yell about passwords, and I have been doing it for a really long time, I think I even made a comment against the Rainbow series on passwords some time ago. But I used to keep all my rants private, and I went public in 2013 doing a presentation at the RSA conference. It was one of these new 20-minute recording conversations, and the title of my talk was "Everything We're Doing with Passwords is Wrong." And at the end of that talk, a gentleman, Ralph Spencer-Poore, who is a very cryptographically astute person leading that process within the SSC, said to me, well, you're aware that we don't create standards in the SSC, really. We kind of refer to the ones that are out there, de jure or de facto. And I said, no, I didn't realize that you restricted yourself that way. And so that's essentially it. That's exactly why, in terms that essentially the standard that you see, the DSS right now, 3.2.1, is actually built on standards that were existing in April 2016. And what were those standards? Well, there were some standards for multi-factor authentication, so you find that in the 3.2. Minimum of 7-character alphanumeric characters. I giggle every time I see 7, but if you went out and looked, and you looked on the web and said, what's the limit on character size, you found a well-known accepted one that said like 7 or 8 characters. Okay. Then the one that I consider most onerous and most useless, the change at least every 90 days. Change your password every 90 days. Don't we all hate that? And then a requirement, which makes a lot of sense, that you securely store and transmit passwords. You don't send them in the clear. You don't save them in the clear. Well, what's happened since that date of April 2016? Well, probably one of the big things is NIST produced the third revision of 863 Digital Identity Guidelines, and they did it in 2017, and it came out as like a 3-part standard. And the one that we're most interested in is the authentication and lifecycle management, which is 63B. And it replaces the authentication guideline that's 2004, 2006, 2011, and 2013, which has all those password statements in terms of syntax complexity and changing your passwords that we all have grown to know and love. Now, my favorite one is 2019, and I'd like to shake the hands of the person who actually wrote this. Microsoft, in their release notes, put it in that note. Periodic password expiration is an ancient and obsolete mitigation of very low value, and we don't believe it's worthwhile for our baseline to enforce any specific value. That's a pretty strong statement, you have to admit. And then most recently, Carnegie Mellon put out a paper, and I love the title. It's very short. Practical recommendations for stronger, more usable passwords, combining minimum length, minimum strength, minimum length, and blockless requirements. And you may recognize one of the authors, Lori Faith Craner, who's essentially been leading this effort and looking at passwords for over 10 years. And one of the things that I consider to be indicative of an increased interest in passwords is that the closing plenary, the very last closing session for everyone at this year's RSA conference, where one of the two guests was Penn and Teller, she was the other guest, and she talked about passwords at plenary level. So that's an indication that there is increasing interest in how to handle those passwords. Now, it said April 2016. Well, that's a long time. It actually is longer than it's been between any other revisions. And although there have been a lot of other standards being developed that look at various parts of these things, the DSS itself hasn't been changed. Well, there's going to be this DSS 4.0. And it's already gone through one request for comments from all the stakeholders. That's from the brands, that's from organizations like mine, Avertium, that are involved in doing with it. That's merchant organizations who join this as participating organizations. And so they put out a RFC, and they got a phenomenal response back to the first RFC. And at this most recent annual community meeting, that's what they call it, a community meeting, they described essentially what they were doing with all those comments, and some of those comments were mine. And they came out with another version of the standard and initiated another second RFC, and that just closed on 13 November 2020. Okay. Now, one of the interesting things, I mentioned compensating control, which is a way to essentially to stop the standard from being so prescriptive, has actually been really significantly improved in this thing called customized approaches. And rather than just a compensating control that's done at the end as an annex, it now is actually can fit right in there amongst all the requirements. You can say, yes, I met this requirement, but I did it with this, essentially a customized approach. And essentially this is a risk-based approach. We expect the DSS 4.0 to be published in 2021. That means they've got a lot of comments they have to look at. And when they do, then this will be essentially the new DSS 4.0. Now, we have an overlap period with 3.1. And because the DSS 4.0 is such an extensive set of changes, essentially they're going to allow you to still meet with the requirements with 3.2.1. And you can do that up to the second quarter of 2023. In other words, they're giving you essentially 2 years to overlap. And that's because, in fact, the extent changes are so extensive. You can begin any time to actually do DSS 4.0 once it's been published, but you can also delay for at least 2 years. And because there are some requirements that are so new, they're not just replacing requirements, they're updating requirements that have existed. And the SSC recognizes that there might be an extensive effort to actually comply with this requirement. Some requirements are declared future dated, and all those future dated requirements will actually be required to be put in place by the first quarter of 2024. Now, the interesting thing, of course, is that it's not published. So I can't stand up here and tell you this is what the DSS is doing. So essentially, for two reasons. Number one, there was a significant change between what you saw at RFC 1 and what you saw at RFC and what will probably happen with RFC 2. So you can't just say what's going to happen. And number two, hey, guess what? We're all under non-disclosure for a lot of these reasons. They do not want a lot of people poking in on this one, and therefore I can't tell you that the standard says this or that. But I can essentially talk about what kinds of things were looked at and what some of those responses might have been. So they basically said, thou shalt not live by passwords alone, and you need to be using multi-factor. And 63B by NIST basically says multiple factors make successful attacks more difficult to accomplish. And throughout that document, they keep emphasizing how, even though they've given a lot of guidance on passwords, they'd really like to see passwords, or memorized secrets as they call them. They'd like to see passwords coupled with two-factor authentication. Now, the current DSS requires that all external and all administrative authentication, be it external or within your enterprise, be multi-factor. So they've already got that requirement, but we can expect to see essentially some more things in DSS 4.0. And in fact, in their recent community meeting, they did a discussion on all the stuff that came up about authentication factors and two-factor. And they made a good point. They're doing some good thinking about, not all two factors are created equal. There are some two factors which may not really be two factors because one factor is dependent on the other factor. So for example, in an iPhone where you use face recognition to unlock a password and the password is sent, but there's not two factors being presented to the authenticating entity, so to speak. So there's some good looks on that. So I recommend following that conversation, even participating in it. The other interesting thing that appears is that they may, in fact, if you're running two-factor, allow a little more latitude in what the rules are for the first factor, the something that you know. Length and syntax. 863 still states 8 characters as a minimum length. I find this a bit frustrating. I actually have friends and colleagues who sit in on some of the NIST meetings, and one of them told me that during that discussion they mentioned that I had argued for 16 characters, that's what I felt it should be. And essentially someone stood up and said, well, I don't want to type in 16 characters on a phone keypad. So in other words, they kept the 8 because on some devices, long passwords might be painful. I don't really like that rule, that decision, but what can we do? The CMU paper, which is this great long study, suggests 12 characters without a syntax requirement as a good balance. Okay, they weren't so keen on block lists. I want to study that paper some more because they mostly looked at block lists in terms of guessing passwords as opposed to offline attacks. And they did mention large block lists as a problem, but there are not a lot of people doing that. So it's a very interesting study about how you would actually do that. So in addressing comments to the RFC, the SSC stated that it received significant resistance to people who said, hey, I don't want to implement that. So I'm arguing, well, let's don't think about this as checking every possible password when someone proposes one. Let's run a reasonable thing, the top 100, 1,000 passwords, don't use those, okay? And then go ahead and give that password to someone, and then continuously in the background, because the list of compromised passwords is always growing, kind of continuously or on some sort of schedule, take a look at the hashes of the passwords you've got and compare them against the hash words, bad passwords, and every now and then tell the user, well, hey, you need to change your password. So it would be nice if somebody would actually look and see if that's a feasible implementation approach. Now, the one I really hate, of course, is the forcing the prophylactic change of a password. And so the great thing about 63B, it doesn't require one. It says you should really only be changing a password, and it became a shall, when it's been compromised. And so, good deal there. The SSC is considering a risk-based approach, and that's good. So, effectively, you should be looking at doing this based on risk. Password storage, what the standards say. Well, the data security says using strong cryptography render all authentication credentials, passwords, phrases unreadable. And that's all they say about it. They don't really talk too much about how you do this. And incidentally, they also talk about account numbers, primary account numbers, how it's possible that rather than using encryption, you can use hashing to store a primary account number. And they just say hashing. They don't say much else about it. Whereas NIST went into some really great detail about how this should be. They said verifiers shall store memorized secrets in a form that is resistant to offline attack. The SSC is really aware of all this stuff, and in fact, they invited me to give a talk at the PCI community meeting, and I gave a talk which basically was saying, that hashed passwords and incidentally hashed primary account numbers are under significant more threat now because you can buy cheap hardware who's essentially been stimulated by the cryptocurrency environment to basically generate, and I love their metric, trillions of hashes a second. So all of a sudden now it becomes very practical for someone to sit there and say, well, if I've determined exactly what your salt is and what your iteration is, I can essentially generate against a large password dictionary what all the hashes are, and then if I've exfiltrated hashes of yours, do a comparison. So we need to find a better answer for that because of this. So 63B suggests using memory hard hashing. And you're the password group, so you know what that is. And it mentions specifically Balloon as an example. Well, you of course all know about Argon 2, and you're saying, well, why isn't Argon 2 not mentioned? Well, the reason is if you look at the document, if you look at 63B, it basically talks about using a standardized hash function. And Argon 2 uses Blake, or a variation of Blake. And because it's not a standardized hash function, as far as NIST is concerned, Argon 2 doesn't get listed. But what about Blake? Well, we know that Blake was among the finalists for what was going to be essentially the SHA-3. And why wasn't it chosen? It wasn't chosen because it was too slow in certain hardware implementations. And of course, we would consider that to be a desirable factor in our problem about passwords. So Argon 2 should be just as acceptable. And like I say, it's just a suggestion by NIST. However, NIST also suggests something that's very interesting. It suggests that a password hash with an appropriately sized salt, where the salt is kept secret on, say, for instance, an HSM, will resist attack. And so think about that. We know that salting is a great idea to stop these tables and so forth. But the problem is with this hardware that's out there that you can buy, if I can exfiltrate a collection of hash passwords, I can just as well exfiltrate the salt that was used to create those passwords, and I can look at the code and basically determine how many iterations are being required for. And so when I can do thousands of hashes per second, it becomes reasonable for me to do reasonable sized dictionary attacks. And so what can keep that as a proper defense? Well, that's keeping the salt a secret. And of course, the only way to really keep things secret is with an HSM. Now, the credit card industry already is used to specialized HSMs. They have a situation where I might be using one cryptographic key between a payment device and the application reading it, and another key that's being used to protect the data when it's being sent to, say, for instance, a processor. So you'd have to decrypt from one key and re-encrypt with the other. And while you're doing that, if you're doing that in the application, it's exposed. So they basically created a payment HSM where you can actually invoke a command to the HSM saying, take this message, and it'll automatically decrypt from one key and re-encrypt with the other. So the text is never exposed. Perhaps an HSM could apply the generalized salt to a password and hash. In other words, it becomes another function specifically in HSMs, which are normally just store things. So we'd want the HSM to generate salts. We probably want it to generate different salts for different passwords, because this addresses the problem if for some reason the same password is used by different people in an organization, which can happen. It's the birthday problem. And so you'd want to be able to couple that, the generation and what the salt was used. And also, we need to decide whether or not iteration is useful. If iteration is useful, then we can do some of the iteration in the HSM, not so much because we don't want to overload it, okay? And then we can bring that result back into the server and essentially iterate it some more. Now, the interesting thing is that since an attacker would not know how many iterations had been done in the HSM, they now no longer know the salt, and they now no longer know the iteration, and therefore it would be difficult for them to use this really good hardware to effectively do this problem. It'd be interesting to see if someone could look at this. So if you have any questions, I'm going to be online, I understand, to answer them. Or otherwise, feel free to email me. Thank you very much.